Well, thank you again to Gray and the conference organizers. This is a ton of fun. I've really enjoyed it. Today I'm going to be talking about reproducible data processing with Go. And some of you might not consider yourselves data analysts or data scientists, but at some level, as programmers, what we do is data transformation, right? Whether you're writing a web application or you're doing CRUD for a database, you're making data transformations. And so it's important for us to know why reproducibility is important, whether you're a Go programmer, a back-end engineer, or a data scientist. So that's one thing I'm going to be talking about today. The other thing I'm going to be talking about is really in the context of, what you might consider smarter types of data processing, like machine learning and other things. How Go is creating, how we are creating Go-based applications that are really changing mindsets in that community and providing a lot of tooling that I think is very needed in that community to improve workflows. Oh, that's not a good sign. Now we're good. All right, so I'm going to start talking about reproducibility, why we even care about it, and really some best practices that you can implement in your code, in your data processing to help you achieve reproducible workflows. And then we're kind of late in the day, and I know we all want to have a little bit of fun, so we're going to do a pretty fun demo, and I think you guys will like it. And finally, I'll just give you some resources. So why do we care about reproducibility? The first reason I would say is that because we all collaborate. Okay? So none of us are working alone. We're all working on teams, and it's really important for me to be able to write some type of analysis or some type of code and be able to give that to my teammates and then to be able to reproduce it exactly such that they can give me feedback on it, such that they can improve on it, such that they can build on it. Also, it's important because, I don't know about you guys, but I kind of forgot what I did yesterday. I think there was like some kind of event stuff and I don't know, some stuff. Anyway, I forget what I do. So I need to be able to go back and see what did I do yesterday, what did I process, what results did I create, such that I can iteratively improve on myself, such that I can build interesting applications. And then finally, there's another aspect that's becoming increasingly important, especially in certain industries, but in general as well, and that's compliance. So I don't know if you guys know, but there's some new laws passed in the EU telling, they're not fully implemented yet, but basically saying that any EU citizen has a right to an explanation for any algorithmically made decision that impacts them as a user, which, if you guys think about what I just said, should scare you quite a bit. Because what it means is, we're not in the EU, but any EU citizen that comes here, if we process their data, that's like their fingerprint, they own that. And they have a right to an explanation for what we do with that data. If we're not able to even reproduce what we're doing, we have no chance of providing that explanation. And in that same vein, if we can't reproduce what we're doing, we have no chance of debugging what we're doing, maintaining what we're doing, and improving on it. So how can we achieve reproducibility? I'd like to share two kind of best practices with you that I like to keep in mind. First, which should be in this audience of Gophers, it should be well accepted, is that we should all strive for and celebrate simple solutions to problems. So just because Google is training some model to play a board game, and there's people driving cars with really complicated neural networks, for the most part, we're not solving those problems day to day, right? Most of us don't necessarily need to implement a convolutional neural network to provide some insight into users on our site or something like that. So I think we're going to strive for simplicity. The other thing, which is really specific to kind of the data processing context, is that we need to version our data. So if we start thinking about data processing, analytics, machine learning, it's really not enough that we version our code, because especially for things like machine learning, if you train your model with a different training data set, you can produce vastly different results. So in order to actually reproduce something that we've done in the past, we really need to be versioning our data along with the code that's processing it, and know what data was used to train which models, or what data was used to produce certain aggregations. And so this is really important. Okay, that's all the serious stuff. Okay, now we're going to get into a demo. All the code and everything is available here. There's a link. There's also a link at the end in the slides. You can play around with this. And what I thought is, we want to create, in thinking about what demo I would give at Capital Go, I was thinking, I want to show them something that might be useful for them day to day, and thinking about what's useful in DC, and also, what's something interesting that we can build. I decided that we'd build a Trump Finder, and we're gonna build Trump Finder version 1.0 today, and it's gonna be pretty cool. We're going to be able to, as I'm sure you guys in DC need to every day, you're processing your images from your tweets, and you're taking pictures on the streets, and you really need to, in an automated way, figure out if Trump is in that photo for various reasons. And this is going to be pretty good because we're going to do it with bigly data. And what I really mean by that is that we're going to create a data processing pipeline that is able to be put into production, is able to be scaled, but also maintains reproducibility, and allows us to deploy our code in a simple fashion and maintain complete reproducibility around all of our processing. Sound okay? All right, cool. So here's the man himself. I'm going to kind of describe the workflow that we're going to go about. So we've got a bunch of photos of Donald Trump, photos of his face in particular. And what we're going to do is we're going to use this really cool project which just came out from a couple people you might know in the Go community. You're probably familiar with Matt Ryer and things like Gopherize Me and other things. But they've created this really cool project called Machinebox. And the goal with this, which totally fits into my philosophy around this, is producing kind of starter packs or batteries of machine learning algorithms that will run in a reproducible way and are easy to interact with. So what you can do is you can get a Machinebox. It's basically a Docker image, and it'll run an API that will allow you to do things like facial recognition, which is what we're going to do. So we're going to use a Machinebox. I'm going to take in Donald Trump photos here, run it through my Machinebox, and this is going to output a persistent version of a model that's able to detect these faces. So this model, you can think of it just like a bunch of parameters of a function. So we input an image and run it through this model, and it tells us if Donald Trump's in there. Then we're going to spin up another Machinebox, because we actually want to identify Trump in photos, right? So that's going to take in our model that we've trained, along with various photos that don't have Trump identified in them. And it's going to output some JSON files that basically tells us, is Trump here? Did I match anything? And if I did, where's he at in the photo? Does that all make sense? Okay, so this seems pretty reasonable. I think if we were, in a, startup Trump Finder, and we were all discussing this, would be a pretty good workflow. But if I came up with this as a member of the team, and I'm kind of showing it to the rest of my team, really what they don't really see this. Especially if I just share a repo with them, kind of what they see is this. If they're lucky, and I include some images in the repo, they see a bunch of references to Machinebox and some files, and I reference this and I reference that, and it's really kind of a big mess. I mean, it's not really reproducible. If I give this to someone else, they're not really going to be able to reproduce that flow that I've shown. So this is where this project Pachyderm comes in that I work on. So Pachyderm is an open source project, and it does distributed processing, data pipelining, and data versioning. So remember I talked before about how data versioning was key to reproducibility for data processing. And this is how this is going to look in Pachyderm. It's basically the same flow that I just showed you, except each one of these cylinders is a version data set. So Pachyderm versions this data in what we call data repositories, okay? And so we know the state of that data at any point in time. Then in between, in our data pipeline, we can use any Docker images to do our processing, but in this case, we're going to use these Machinebox Docker images to do this processing. And now what I've created, because I have this pipeline set up in this way, and because each one of these repositories is versioned, I can do things like say, this result resulted from this particular image, which was trained with this particular set of faces, right? So at any point in time, I know exactly the provenance of my results. And as I update the data, as I run my pipeline more times, I know I have complete reproducibility over this. Now, lastly, those JSON files aren't super interesting and visual, so I'm just going to add my own little tweak to this, which is another pipeline stage written in Go. And I'm going to take in some label files, and I'm going to take in those unidentified images, and I'm going to take in the coordinates of where the faces are, and I'm just going to tag them in the images so we can see them visually. Good? All right, cool. So let's actually do this. Let's see if Mark didn't take away all the good juju for the. All right, see if I can connect. Okay. So what I have here is a Kubernetes cluster. You guys don't have to worry about too much of this. Just see that Pachyderm is running in this cluster, and that's what we're going to be interacting with. So Pachyderm is just an application that runs in this cluster, and that's what we're going to interact with this CLI pack control. Now remember, all of our data is going to be versioned in these data repositories, and right now I don't have any data repositories because I haven't created any yet. So let's go ahead and create a few repos. So first we're going to create one for our training data, which are our faces. Then I'm going to create one for these unidentified images. So is that spelled right? Close enough. All right. And then I'm going to create one for those labels that I mentioned. So those are the three input repos that we had, remember, over here on the left, that are going to drive everything. So now we have those three data repositories, and there's nothing in them, because we haven't put anything in them yet. So let's now see where I'm at. What I have here are a few trunk faces. So what I'm going to do is I'm going to put those into the training repo on the master branch, again, thinking like Git for data. So let's put those there. And now I can see that I have data in my training repository. So I have the data I need in order to run this top bit of my, my processing pipeline. So let's go ahead and create that top part of the pipeline. Find where I'm at here. Okay, so what I have is this specification, and this might look complicated, but what I'm doing is I'm saying create this model pipeline, and I'm going to run this Spacebox image, Docker image, which is just based on the Machinebox image. And I'm going to do some things in that image. First off, I'm going to run Spacebox, which is allows me to do what I'm going to do. And then I'm just going to post those images to the model. Remember, the Facebox provides a JSON API for us. Finally, I'm going to tell Pachyderm, I'm going to say, do all that on my training data. So this is the input for this model. So let's go ahead and create that. And now, something interesting has happened. Now, if I look and see what jobs are running on my Kubernetes cluster, Pachyderm has actually spun up a job here. And what's happening is it's saying, there's data in my training repository that hasn't been processed yet. And you've told me that when there's data on that input, to process it with that image you told me about. So I'm going to go ahead and process that. And so that's what's going on here. And hopefully here in a second, oh, sweet. So we had a success. Sorry, it's a little bit smaller. And also, now if we look, you can see we have one more repo here that wasn't there before. And what that repo is see what's in there. That's the state of my model. So remember, I'm creating this model, and Pachyderm is automatically versioning the output of that stage. So it automatically created that data repository. Great. Now, let's go back here, and let's put an unidentified image in here. I have a couple of these. Image 1, let's see what that looks like. Okay, so we've got that guy, and then we've got this one. Okay, let's go ahead and put those in our unidentified repo on the master branch. Now, I have those there, but I actually haven't created this second piece. So I have unidentified images in this repo, but I haven't created this second pipeline. So let's go ahead and do that. It's very similar to the first time around. I have another one of these pipeline specs. It does almost a similar thing. It's just a different request. Okay. And now when I do that, I can see Pachyderm again has started running a job. Let me actually pull this up. So it started running a job, again, because I put data into an input data repository. And it said, oh, now I know that any data coming into that unidentified data repository, I need to run through the identify data pipeline. And that data pipeline ran, it pulled in our model, and now it's performing this identification. Hopefully it'll actually finish here in a second. And so now we've created this whole top part, all the way down to the bottom. So let's see, it should take just a second, maybe more first time around that it runs. Sweet. Success. Now, if I look at my repo, again, I have all the ones I had before, but now I have another repo that versions the output of my identifications. You can kind of start to see how I'm chaining these repos together, and they're all kind of connected. If I look at what files are in that repo, I can see that there's two. Let's look at one of them. And you can see here in my JSON, I've identified Donald Trump in that first image at that location. So my Facebox facial recognition worked. It's pretty easy to set up. But again, this isn't very fulfilling to our being visual creatures. So let's go ahead and create this last bit. And to do this last bit, I created this Go program. And this is actually the first time I used some of these packages, so it's kind of fun. I don't know if you've used image draw yet, but basically it lets you do things like, so like right here, I'm taking in my label image and I'm taking in my other image. And basically I'm just overlaying the one image on the other image at the particular location of the face. All right. And so to do that, I need to actually add in those labels. Okay. Here you can see I'm just going to use something familiar that we've probably all seen a little bit in recent times. So I'll go ahead and put those there into labels. And then I'm going to create this tagging pipeline. So this tagging pipeline is just going to run the binary of my compiled Go binary to do that tagging. Okay. See if I did beat it. It should run pretty quick. Give it a few seconds here. Cool. So now, again, if we look at our repositories, we now have this last one with data in it that versions that last bit of our data processing. Let's look at what's in there. Oops. I've got 2 files. Moment of truth. Let's actually see if this worked. Fingers crossed. There we go. There he is. There's one more of them. There we go. Cool. So we have that. Now, the very last thing I want to show you is, remember, we've set up this whole thing. We have this chain series of version data repositories with some processing in between. But this really gets powerful when we change something, right? When we update our data, when we change something, is really when reproducibility gets important. So if we go here, I don't want to seem partisan or anything. So we have some other faces to teach. Okay, so let's go ahead and put those into our training on the master branch. Okay, and this should be pretty fun. Now, a few things are going to happen here. So remember that we have this whole thing set up. And what I just did is I changed this data. And since the data is version, Pachyderm knows that data changed, which means that this data and this data and this data aren't in sync with my latest changes in my input, right? So Pachyderm says, oh yeah, well now I need to retrain my model, so I'm going to rerun that on my updated data set. And then that outputs new data to here, right? And then Pachyderm says, oh, now I've got changes in my data here, which means that this repo and this repo aren't in sync with that latest change. And so what it's going to do is it's going to rerun my identify. And then, once it reruns that identify, of course, this isn't in sync, so then it's going to update this. So hopefully here in just a second, everybody, hold your tongue right. All right. There's one more, just one more, please.
Should have ran 1 million workers.
I should have ran last night. Last night I ran 42 and it didn't crash things, so I probably should have just done that today. All right, it should work hopefully here in just a second. And you can see that I've got the hashes for the results for each of those cases. So I know exactly the commit ID for all of my previous results. And if I was to look in any of those repos with those commit IDs, I could see any previous state of my data. So finally, let's look at what's here. Okay, again, I've got those two. Let's get this last one. Display it. There we go. All right. So you can see how easy it is to do this, and if just to illustrate this reproducibility part, I told you that I could show any previous version of the data. So if we take that same command and we give it that previous commit ID, we have the previous result and all the data that goes along with it. So that's all I wanted to share with you guys. Here's some resources. Run the pipeline. It's really easy. Contact me. I have some elephant stickers. We've already got buffalo stickers. Come and find me. I'll give you an elephant sticker. Chat with me and connect with these great resources that are out there for data gophers. Thanks.
We can take one.
So why is it, those images were pretty small, like 500 kilobytes or so. Why do you think it took a long time to run?
So the reason why it took a long time was because basically I was spinning up that machine box and instantiating the model. So they're in the process of developing a little bit of tooling around that that will much better fit this use case rather than working with like a persistent JSON API. So that's kind of a work in progress. Yep.
Excellent. Let's take one more. You had one.
Yeah, I was wondering if you implement any ways for dealing with streaming data, or if not, what is your advice for reproducibility when dealing with streaming data?
Yeah. So in Pachyderm, if you noticed, all of my results updated anytime I updated any one of the inputs. So the difference between streaming and batch processing in Pachyderm is really the frequency of your commits. So if you commit,
a ton of hashes.
what now?
You're just gonna have like a ton of different.
You'll have a ton of different ones, but those are very, very cheap. They're very lightweight as far as like the actual data that you need to store to have those. And we're hoping to build some more UI stuff around that to help with that use case as well. Thanks.
All right. Well, thank you, Dan.
Yep.
Great.